In my last video, I went into depth about Thea's collision, which essentially was the creation event of Earth's moon. So what happened is that 95 million years after the creation of the solar system, Earth collided with a large planet that, and the debris from the collision created Earth's unique and large moon. So this, I talked about the 30% rule. So what the 30% rule is, if you could take into consideration that the sun is getting hotter and will boil Earth's oceans in 1 billion years, and if you take into consideration the fact that Earth took 3.8 billion years to go from single-celled organisms to civilization, you can deduce that any aspect in Earth's history that increased Earth's evolution speed by 30% or more was crucial and can be thought of as like a filter to civilization. So Thea's collision followed the 30% rule in 3 independent aspects. The first aspect is that when Theia crashed into Earth, it deposited volatile elements on Earth's surface that normally wouldn't be there, which are crucial for life. Secondly, Theia hit us at the correct angle and created a massive moon, which essentially resulted in Theia having an ideal, Earth having an ideal tilt, and then the moon, because it was really massive, made Earth stay at that tilt, which essentially resulted in stable seasons on Earth for a very prolonged period of time, which is, obviously still going on. And then lastly, it created because the collision was so big, it created plate tectonics on Earth, which is necessary for life. So yeah, so this essentially means that Thea's collision is a filter because it follows the 30% rule in 3 different independent aspects. However, in this video, I'm going to be going into depth about other events in Earth's history that follow the 30% rule. So the first one I'm going to be talking about is the event of fish transitioning to amphibians. So amphibians are necessary because civilization must take place on land. So we would need fish to become amphibians and then amphibians to become terrestrial animals. So the question here would be, are amphibians natural? Meaning, okay, if we give fish like any arbitrary amount of time, are they just naturally going to become amphibians? Or scenario 2 is that fish won't become amphibians, and like the only reason they become amphibians is because of like specific pressures that result in like unique conditions. So I'm going to be arguing that amphibians are not natural, and that the reason amphibians happened on Earth is because of a supernova that caused the Devonian extinction event. So the Devonian extinction happened 375 million years ago, and the first fish, like the transition of fish to amphibians, like the first fish that had legs and other various adaptations was a fish named Tiktaalik. And Tiktaalik also first showed up in the fossil record 375 million years ago, which is exactly immediately after the Devonian extinction started. So, and then amphibians came 7 million years later. So in the description, there's a study talking about how likely a supernova caused the Devonian extinction. And they also, so essentially what happened is that UV radiation from the supernova destroyed Earth's ozone, which caused like a lot of problems. But this supernova would have also released 100,000 years of ionizing gamma rays. So gamma rays are ionizing, which means that they have the ability to damage DNA, which causes mutation. So essentially, I argue this created amphibians because they created an increase in mutation rate that allowed the evolution from fish to amphibians to be like super quick, which allowed Tiktaalik to exist. And then once Tiktaalik existed, it wasn't that hard for it to become an amphibian because it was already like kind of walking on makeshift legs, and it had like almost lungs and other various adaptations that allowed it to become an amphibian. And like notable is the fact that fish first existed 530 million years ago. So they essentially existed for 155 million years. And then Tiktaalik showed up immediately after the Devonian extinction, and then amphibians showed up 7 million years later. So this evidence would suggest that amphibians are not natural, and that the reason we have amphibians is because of the supernova that caused the Devonian extinction. Okay, and so the next event in Earth's history that I'm going to be going into detail is the impact that caused the end Cretaceous extinction. So this is kind of harder to argue than the amphibian one. So essentially, I'm going to have to be arguing three different conditions. So the first thing is that mammals are social, so they can develop civilization. And dinosaurs are antisocial, so they can't develop civilization. And dinosaurs are always dominant, more dominant than mammals. So essentially, like this impact that killed dinosaurs and allowed mammals to live and then become the dominant species on Earth, allowed civilization to exist on Earth civilization to exist on Earth, which normally wouldn't exist, because normally when land animals exist, they're always going to be dominated by dinosaurs, and mammals are never going to be like the main life form on land. So why are mammals so smart, and why are they able to develop civilization? So I argue that the reason essentially is because mammals give live birth instead of laying eggs. So live birth, essentially a mammal is vulnerable during pregnancy, and then they give live birth to a vulnerable offspring, which means that mammals are incentivized to parent their young and take care of their young extensively. So I argue that this leads to social structure and family units. So we can see lots of examples of this, like orca whales. They teach their young like lots of complicated, ways to like outsmart seals, and they have like a very complex parenting deal. We could also see like chimpanzees. They also parent their young. They have very complex social structure. They have family units. And there's like various other examples of mammals that do this. You could take big cats, like basically all the primates, orca whales, dolphins, etc. All of these are examples of mammals with complex social structure and parenting and family units. So the reason this is important for civilization is because when you exist in a family unit and a complex social structure, intelligence is selected for. So like fast learners, good parents, and good socializers are all going to benefit a family because they're going to be good at collaboration, and they're going to be good at like just helping the family exist as a whole. So, and these three qualities all require intelligence, which kind of means that mammalian family units are like AI singularities, because like, okay, first a social structure is created, and then this social structure will select individuals that are smarter, because you have to be smart to like learn how to socialize. And then those smarter individuals will create a more complex social structure, and then that social structure will select even smarter individuals. So like this process will keep continuing on and on and on, and the mammals will get smarter and smarter until the mammals learn how to create tools if they have like hands, and then the mammal will try to teach their kid how to make tools, and then that'll be really hard, so then they'll invent a language to do it. And then once you invent a language, you're going to become a civilization. And yeah, so that's how civilization existed on Earth, because mammals became the dominant species. And I argue dinosaurs can't do that because they're really antisocial. And this, like evidence of this, is the fact that they buried their eggs and abandoned them, kind of like turtles. So mostly, rather than having like pressure to be intelligent, dinosaurs essentially were just like, okay, get bigger, get stronger, and that will increase your individual survival rate. Okay, so the next question is, why are dinosaurs more dominant than mammals? So there's a variety of reasons, but the first one is that they came first. So fish goes a fish, amphibian, reptile. Mammals and dinosaurs came from reptiles. Dinosaurs are just basically big reptiles, and then mammals are basically like reptiles that somehow developed the ability to give live birth. And so as a result, dinosaurs, there are already large dinosaurs that existed 20 million years before the first mammals existed. Um, and the second reason would be eggs. So because dinosaurs lay eggs, one, they're not vulnerable during pregnancy. Um, Egg laying is just better in general because it's like you can have more offspring, which means you can evolve faster. So fish lay eggs, amphibians lay eggs, and reptiles lay eggs. Um, and lastly, dinosaurs are just way bigger than mammals. So there's a video in the description like describing all the reasons like why dinosaurs became so big. But basically, it's for three reasons. One, because they can lay eggs. They can become bigger because live birth doesn't scale well with size. Like if you take the elephant, for example, elephants are pregnant for 2 years, which means like you would have to just be, by being as big as an elephant, you would have to be vulnerable for 2 years to give birth. And if you look at like a sauropod, for example, these big guys, if they were pregnant, it would take like forever and it just wouldn't be sustainable. So because they can lay eggs, they don't need to be vulnerable forever and they can just they can have many offspring rather than just like having one or two. Um, Another reason is because they're mesothermic, which is kind of in the middle of warm-blooded and cold-blooded. And the fact that they're mesothermic means that essentially their metabolism is more efficient, which means they have to eat less food to like maintain, just like they have to eat less food to survive. And as you get bigger, you're gonna have to eat more and more food. So like as you get bigger, it's less and less sustainable to be warm-blooded. And then lastly, um, they have a pneumatic skeleton, which is described in the video. So like sauropods have a hollow spine, which essentially is more structurally sound as you get bigger and bigger. And mammals can't do this for some reason. Not really sure exactly why, but yeah, I think they describe it in the video. But anyway, so that's basically why dinosaurs are always going to be more dominant than mammals because they both came from reptiles and dinosaurs came first from reptiles and they were just bigger and better and more scary. Okay, so what happened in this extinction event that caused dinosaurs to die and mammals to live? So um, it was caused by a large impact, and this impact hit the Yucatan Peninsula, and at a 60-degree angle, which essentially caused like a large blanket of debris to cover all of Earth. And this debris stayed in the atmosphere for up to a year, which means for a whole year, Earth was completely dark, which means there was no sunlight, no photosynthesis. Everything was really, really cold. Um, Also, the debris was really hot, which essentially caused like global forest fires because like the debris fell down onto plants. And another aspect is that because the Yucatan Peninsula has like a lot of sulfur-rich rocks, the collision um, created a lot of sulfur and put it into the atmosphere. So sulfur is really bad in large quantities in the atmosphere because it created an extreme um, cooling effect for 10 years. So sulfur is essentially kind of like the debris, except it's semi-dark and not 100% dark. So um, the debris, on the other hand, though, took 10 years to fall out of the atmosphere instead of the 1 year. I mean, the sulfur took 10 years to fall out of the atmosphere instead of the debris that only took 1 year. And then as it fell down, it created acid rain, which is also really bad for plants. So the first two aspects of the collision were just really bad for plants because all photosynthesis was halted and likely all the plants that needed photosynthesis to survive died. And then also there's forest fires and acid rain, which is really also really bad. Um, the last important detail of the collision is that right before the impactor hit, there was a large mantle plume that erupted in the Deccan Traps, and because of the earthquake that was caused by the impactor, the eruption was amplified a lot. So we can kind of see this illustrated in this chart. So this side is distance away from the earthquake, and this side is how big the earthquake is. So the epicenter of the earthquake caused by the impact was 11 magnitude, and it was essentially 9 magnitude globally. So this essentially would have caused any volcano that was like active to erupt. And because the Deccan Traps was already erupting, it caused the Deccan Traps eruption to be like much stronger. And we can kind of see like this means global effect. So 11 magnitude would create a global effect. So yeah. So why did this extinction event cause dinosaurs to die and mammals to live? So for the first decade, it was really cold, and likely even the equator was below zero. So this, in the first decade, likely most of the dinosaurs died just because, you know, there's cold weather, and dinosaurs are really bad in cold weather because since they're mesothermic, they don't have a very good like body temperature regulation system, whereas mammals do, and also mammals have fur. So mesothermic dinosaurs do really bad in poor weather. Also, like all the plants were dying, and like there's forest fires everywhere, and there's a gigantic earthquake, there's tsunamis. So it's just really bad news for essentially everyone. And so most of them died in the first 10 years, likely, but there's probably going to be some stragglers. So, and the reason that the stragglers died is because the plants died because there was no photosynthesis, which caused the herbivores to die. And dinosaurs were either herbivores usually or carnivores that ate herbivores. So because the plants died, the carnivores were left with no food, and then the carnivores had to eat each other, and then eventually the carnivores died too. So essentially there was no food, and this caused any stragglers that like survived the first initial 10 years to eventually die as well. And finally, the reason mammals lived, well, actually, most of the mammals died, but the heaviest mammal that lived was about 1 pound, and it was like a rat shrew like creature. And the reason it survived is one, because they can burrow. So like if it's really cold outside, or if there's like a forest fire going on, or like something bad is happening, you can just burrow. And also they have fur and warm blood, which means they're better at surviving cold temperatures. And lastly, insects like worms and snails and stuff survived, and the small mammals that survived were insectivores. So they had, unlike the dinosaurs, they had a guaranteed source of food. So this is why this specific impact caused dinosaurs to die and mammals to live. So an important thing I'm arguing is that this extinction event could not have been caused like by a natural, like geologically caused extinction event. So there's two early ways that extinction events can happen naturally. So the first and most common way is volcanism. So like, as you can see, all of the extinctions except for the supernova and the impact were all caused by volcanism. So essentially large-scale volcanism is caused by mantle plumes. So every once in a while, a large blob of magma will start to rise, and then because it's hot, it'll rise all the way to the crust, and then it'll erupt. And every once in a while, they get really, really big. So we can kind of see an illustration of this. Like these are all like the Earth's most recent mantle plumes, and the Siberian traps was like a gigantic one. And the Siberian traps caused the end Permian extinction, which was the worst extinction event in Earth's history, which caused 96% of all life to die. So the reason large mantle plumes cause mass extinction events is because of warming. So essentially, eruptions will erupt carbon dioxide and sulfur dioxide at a 0.6 to 30 ratio, and that's like the range of all the ratios. So sulfur dioxide, which falls like out of the atmosphere relatively quickly, so like in the impact, like all the kicked up sulfur fell out of the atmosphere in 10 years, but carbon dioxide can stay in the atmosphere for like millions of years if there's a lot of it. So essentially mantle plumes, large mantle plumes, will cause an extreme warming effect, and that will kill like everything. And specifically, a warming effect will be worse for mammals because they're warm-blooded, and mesothermic dinosaurs would like warm temperatures would be ideal for them. And we can also see like the first dinosaurs came around here, and this end Triassic was also caused by a mantle plume and like caused warming. So, the dinosaurs survived that, and they probably wouldn't have survived the Great Dying, but also mammals would have died too. So that's mantle plumes. And the other geologic mass extinction that could be caused is like if there's a lot of exposed basalt. So sometimes eruptions will erupt basalt, but also a period in Earth's history called Snowball Earth was essentially where the breakup of the supercontinent Rodinia, which is kind of like Pangaea but older, it broke up and then exposed a lot of basalt to the atmosphere, and then basalt naturally removes carbon dioxide. So all the basalt that was exposed essentially removed all the carbon dioxide and greenhouse gases on Earth, and this created an extreme cooling effect where Earth was completely covered in glacier, and this happened for 10 million years. So essentially, what I'm saying is like the extreme cases of both of these scenarios would either kill both mammals and dinosaurs or not be strong enough to kill dinosaurs and like not mammals. So warming would kill mammals and dinosaurs, or would probably just kill mostly mammals because mammals are warm-blooded. And then the removal of CO2 would create cooling. This would not be able to kill dinosaurs, but not mammals, because either the cooling would create snowball Earth, which would kill everyone, or it like wouldn't be enough to kill the dinosaurs, because like the main reason that all the dinosaurs died was because the plants were killed. And if you had an eruption that was like that somehow like erupted enough sulfur dioxide to kill all the plants, this would also create a lot of carbon dioxide, which would have like bounced back into a net warming effect. So that's also much different from like what happened during the eruption, because the carbon dioxide over sulfur dioxide ratio was much smaller than 0.6, because most of the sulfur dioxide was hit by the impact and not by an eruption. And also important to note here is that the Deccan traps that erupted like right before the impact hit is on this side of the globe, and the impact hit on this side of the globe. So this could suggest that like if the Deccan traps hadn't started erupting before the impact, that maybe some dinosaurs would have lived on this side, and then eventually they would have overpowered the mammals on this side. So essentially what this means is that this extinction event is extremely unique, because the only reason it was able to kill dinosaurs and allow mammals to live is because the impact hit a sulfur deposit, and because the volcanism started, the magma plume started erupting right beforehand, and then the impact caused this eruption to be stronger. So that would have shot even more sulfur dioxide into the air, and the carbon dioxide, since it wasn't too big, the carbon dioxide actually helped the recovery of mammals. And then the sulfur dioxide made the cooling effect even more extreme, which helped kill all the dinosaurs. So this event was extremely unique and probably had to happen the way it did to produce the effects that it produced. So basically the conclusion of this presentation is that essentially we owe the existence of civilization to 3 lucky events in Earth's history. Thea's collision and all the mentioned aspects of rare Earth, which I talked about in my previous video, allowed Earth to be a habitable planet with like a fast enough evolution speed to like get complex life before the sun gets too hot, which just means that Earth was habitable because of Thea's collision. And then, however, even if Thea's collision happens, that doesn't necessarily mean like complex life on a planet is going to become smart enough and like become civilized, specifically because amphibians are unnatural and likely only exist because of the supernova that caused the end Devonian extinction. And then mammal dominance is like even more unnatural and only happened because of the Chicxulub impact, which is the impact that caused the extinction and killed the dinosaurs and allowed mammals to survive and eventually evolve into humans. So yeah, we got extremely lucky. So I guess I'll end the video by just saying that we're extremely blessed. We get to live on this awesome planet. We have oceans, we have lakes, we have good weather, and also there's mammals, and there aren't any pesky dinosaurs, which would probably have killed us really brutally. So just look. Look, our most ferocious predator. I mean, not the most ferocious predator, but like the fastest predator, the cheetah, is like super cute and like cool looking. And then we have orangutans, we have elephants, and mammals. I mean, mammals are just way, way cooler than dinosaurs. And we get to live on a planet filled with mammals instead of dinosaurs, which is awesome. Okay. Bye, everyone.